Okay, so last time we looked at the power rule, which is the simplest way to differentiate, but unfortunately we can't always use the power rule. And so we need other rules which are a little bit more complicated, but they're actually quite simple once we get to know them. So in this question where we have f of x equals 9x plus 3x plus 4 all to the power of 3, the 9x is quite simple to differentiate because we could just use the power rule. So if we were to ask to find the derivative, we would start by saying, well, f dash of x is equal to a 9. So we know how we got that last time because the derivative says, well, we take 1 because it's actually just x to the power of 1. We know there's a ghost 1 here. So it's there, but we can't see it. Yeah, there's 1. So 1 times 9 would be 9. And then x, 1. And then we always take 1 off the exponent. Now 1 minus 1 is 0. So x to the 0, anything to the power of 0 is just 1. So a quick way of thinking of it is anything, and when you have an x which has no exponent, so it's just by itself, the derivative is whatever's in front of the x. So if you had 9 over 2x, the derivative would just be 9 over 2. So that's a quick way of thinking of it. Now, this bit here, the 3x plus 4 to the power of 3, we could times out, which would take a long time, and then differentiate that using the power rule. But of course, if you had something like 3x plus 4 to say the negative 6, we couldn't times this out. We don't really know what to do. So when you have a more complicated function to the power of something, we can use what's called the chain rule. So if you get given it in your formula sheet, it looks a bit complicated, but we will just break it down. And so what's simple to remember is that it's often called the outside-inside rule. So what do we mean by that? Well, we look at the outside as being the function here, there and there. So in other words, if I look at my function, I think of the outside as being the outside of the function. So what I've highlighted in pink. And then the inside is the bit that's in blue. Okay. So let's look at the steps, and we'll do a couple because it is a bit confusing when you first see it. So let's look at the pink bit. So we're thinking of the outside now. Well, when we differentiate that, so if I was to differentiate this using the power rule, 3 times, I do 3 times the front, so the exponent. So let me just say, put a plus here quickly. So there would be a 3 here. So I've differentiated this in terms of the normal power rule, like that. And then I take 1 off the exponent, right? So I've kind of used the power rule. So let's look at that. So if I was to say 3x let's make it more like this one. So if I was to say x cubed, using the power rule, you'd say, well, 3 times 1 is 3x, and then to the power of 2. So that's what I've done here. I said 3 times 3, 5 times 1 is 3, 1 off the 3 is a 2. And so I have this. And then what I do is I just leave the inside alone and leave that as it is. So that's the first bit. So we just say 3 times 1 is 3, leave the inside alone, and then do the outside bit here, take 1 off. So that's the outside. So I've done the outside. And then I simply find the derivative of the inside. So now I'm doing the blue bit. Well, the derivative of 3x plus 4 is just 3. Okay, because the 4 goes away because if it doesn't have an x, the derivative is 0. And then 3x, I know from what I said earlier about the 9x is just 3. Okay, and then I can just tidy it up. So it's just 9 plus, and then 3 times this 3 at the back will be 9. and then it'll be 3x plus 4 to the 2. Okay, let's look at that again. Let's look at another one. So we'll look at 3, and then hopefully that'll be good. So let's say we had f of x equals, we'll make it 4x squared plus, and they're not always going to have a 1 in the front, one of these terms in the front where you use the power rule. Sometimes it'll just be the bit that you need to use the chain rule by itself. But, and we'll do one of those next. So let's make it a negative power. So let's make it 9x to the 4 plus 3x, okay? And then to the power of, say, -2. Okay, so now this is a little bit more complicated because we've got a negative. And so we just need to know how to deal with that. Well, the f dash of x, the first bit, we just use the power rule, right? So 2 times 4 is 8x, and then I take 2 minus 1 is 1. And so the derivative of this first bit is just 8x, right? 2 times 4 is 8x, 2 minus 1 is 1. And when there's a 1, we don't write the 1. It's just assumed when you have an x by itself that it's to the power of 1. Then we look at the next bit, we've got, okay, it's outside inside rule. So you go, right, so what's my outside? Well, that's this bit here in pink. Okay, so the outside, I would say, well, -2 times 1 is -2. So I'm just going to write a minus here. So it actually would have been a minus. So I shouldn't really have put the plus. But when I plus a minus, I get a minus. So I'm just going to write the minus in. When we tidy it up, this will become just a minus sign. The rest of the outside bit, -2, -3, -1 is -3. I leave the inside alone because remember, it's the outside inside rule. So I'm just doing the outside first. Then I do the derivative of the inside. So 4 times 9 is 36. X, and then 4 minus 1 is 3. So 36x to the 3. So I've used the power rule there. Plus, and then 3. Okay. And so I've now got this, which I can then tidy up. So I'll have 8x minus 9x to the 4 plus 3x to the -3 times 36x. 3. Okay, now sometimes they don't want you to have a negative exponent. So what you could do is you could say minus, so this 9x4 plus 3x to the -3, it could go to the bottom and be to the power of +3. So remember, that's from our, when we were doing exponents, one of our exponent laws says that when you take a negative, so in other words, if you had x to the -1, that could go to the bottom and just become x to the +1. So it comes from that rule. So that x to the -3, this 9x4 plus 3x to the -3 could go to the bottom and become +3. This bit here, the 36x cubed plus 3, that remains at the top because it's got a positive exponent. And you could do it like that. And of course, now, we don't have to do anything else. Oopsie. We do have to leave. We don't actually have to have the brackets anymore now at the bottom because this is almost like it's in a bracket. Okay, so that's another example of the chain rule. let's do one more. And we'll do it, it's one where it's kind of more disguised. So we have an f of x, and let's say you got this. Let's make this to the, we'll leave it as square root. So this doesn't immediately look like inside outside, but remember that the square root of x is the same as x to the half. Okay, that's something you need to know. So the square root of a function is the same as that function to the power of a half. Okay, if it had been a cubed, then it's x to the 1/3. Okay, or if it had been, say, x, and we'll do one after this, I think, actually, just one more. This would be then x to the power of 2 here, and then the 3 at the bottom. Okay, so we're going to write this 12x squared minus 3x to the half. And now we're going to go ahead and do our chain rule. So let's use pink. So we're going to do outside first and inside second. And so we have equals a half. Why am I using pink? Okay, a half. Leave the inside alone. A half minus a half is minus a half. And now we differentiate the inside. So 2 times 12 is 24. X, 2 minus 1 is 1. So it's just x. And then minus 3, right? Because if we have an x by itself, no exponent, the derivative is always just what's sitting in front of that. So we've done it. Now we tidy it up a little bit. So we could just say the half is at the top, the 24x minus 3. Well, a half at the top, we could actually just write that half at the top actually as just 2 at the bottom and the 1 at there, which you don't necessarily actually need to have the 1 because, well, let's leave the 1 and see why. So the 24x minus 3 is at the top. And then, of course, this minus a half go to the bottom and become plus a half. Or you could just put that in a square root sign to the half, but we're not going to do that. No, I don't need to write that 1. So I could just say, well, it's 24x minus 3 at the top. And then 2. Actually, I am going to write it as a square root just to show that you can jump between these to the half and to the square rooted. So 12x squared plus 3x. So the half is the same as saying the square root of 12x squared plus 3x. The reason I'm showing you this is because sometimes you might see this in the memo instead of to the power of a half. And so they are the same thing, just written differently. So we're going to do the next on one more question on the whiteboard here, just to solidify this concept. And also just to remind ourselves of some other important things, which is the indice rule or the exponent rule. So let's say that we get our okay. So this one looks a little confusing, but we know, let's make that a 3. We remember from our exponent laws that if you have this, that's the same as saying x, now it's to the power of 3. Then of course, if it's to the square rooted, it's to the half. So you end up having a 2 there. So x to the 3 over 2. Okay, I'm going to do one more example just to solidify that. If I have a 5 and a 4 here, I just write it as x 5 over 4. Okay, simple. Top goes there, and then the outside bit goes at the bottom. So here, I could actually write this as 3x plus 2, 3 at the top, 2 at the bottom. Okay, now I've got my inside-outside rule I can do. So remember that we were doing our outside in pink and our inside in blue. So sometimes if you've got some erasable highlighters, you can use this, or just any highlighters. And then it sometimes just helps to identify what is the inside, what is the outside. So outside first, 3 over 2 at the front. So we'll do it in pink. Outside first, 3 over 2 at the front. So this is f of x equals f dash of x, should I say. Okay, I'm going to do something quickly now. Just remember, also, we can have different notations, right? So if I have y equals this, I can say dy over dx equals. And that is exactly the same as saying y dash or f dash of x. So this dy over dx just means the derivative. So a lot of these things are just notation, meaning the same thing. So we've got our 3 over 2. And then we leave the inside alone. And then we have the 3 over 2 minus 1, which is a half. 3 over 2 minus 1 is a half. So 3 over 2 times the front, 3 over 2 minus 1 is a half. We've done the outside. Now we do the inside, the blue bit. Well, the derivative of 3x plus 2 is just 3, because 3 times x. And then we put 1 times 3 is 3. 1 minus 1 is 0. Anything to the power of 0 is 1. You need to know that. And then the 2 goes away because there's no x. Okay, so we're almost done. We just need to tidy that up. 3 times this 3 at the back will give you 9. So it'll be actually 9 over 2. 3x plus 2 to the half, which I can write as the square root of 3x plus 2. Okay, you will still get marks if you write it like this, though. Okay. I would say, it doesn't really matter how you do it. If you write it to the half, I like to keep it to the exponents. But also, if you have a negative exponent, just to be safe, take it to the bottom and make it positive, because it's just in maths, they find that that's the simplest way of doing something, is to have a positive exponent. Okay, so that is the chain rule.